Today we are going to see some equations with fraction bars, and we're going to learn how to eliminate those fraction bars. So let's take a look at our first problem here, and it says that we have to divide the sum of 4x plus 1 by 5. And in order to do this problem, to isolate the variable x, I'm going to multiply by the denominator of 5. And what that'll do is it'll cancel out these 5s, leaving me just with this 4x plus 1 now equals 25. So from that step, all I have to do is subtract the 1 from all sides, and we'll have our answer shortly. So here we have 4x equals 24. So from that point, we can do some division. We can divide by 4 on both sides, and we'll have this x equals 6. So let's take a look at our next problem here. In the next problem, we're going to end up multiplying by 4 on both sides to cancel out the denominator of 4. And when we do that, it leaves us with the 4 minus 2x, numerator of that fraction, and it all equals negative 8. So from this point, we can go ahead and subtract the 4 from all sides. Notice how we have the same sign there, so we end up having to add those two numbers. So now we have negative 2x equals negative 12. So from this next point, I'm going to divide by negative 2 on both sides, and that leaves me with x equals 6. So let's take a look at our next one. The difference is we've got the constant on the left-hand side of the equal sign, but no fear, we just do the same thing. So we want to cancel out that 2, so you're going to multiply by 2 on both sides. That leaves us with this 14 equals 3x minus 4. So from this point, we could go ahead and add the 4 to both sides. So when you do that, you're left with 18, and 18 equals 3x. Well, we divide by the 3, and we have 6 once more. So x equals 6. Now, 6 is not going to be the answer for all the problems, but it is on those, and I don't think it's going to be the answer for this next one, so let's try it. So Stan's, Fred's, and Mark's ages are consecutive whole numbers. So what that means is like 1, 2, 3. These are whole numbers, even starting at 0, but these would be like their ages. And they're consecutive numbers, so that means just one after the other. It says the sum, so that means if you add up their ages, it's 186 years. So let's do this. We want to find their ages. Let's call Stan's age, we got Fred's age, and we got Mark's age, and they're all adding together to equal 186 years. Now they're only 1 year apart. So instead of having 3 unknowns, which we have right here, we're going to make it so we only have 1 unknown. So we're going to write some expressions for some of these ages. So let's take Stan's age and say that equals Stan. S stands for Stan's age. Stan's age. Well, if that's the case, let's say that since Fred is just 1 year older than Stan, Fred's age would end up being just S, so Stan's age, plus 1 year. And then Mark's age, well, since Mark's is 2 years older than Stan, 1 year older than Fred, we're going to say his age is Stan's age plus 2. So now we've got expressions to represent an unknown. And now we have the same unknown, so we can solve the equation. So we've got Stan's age plus Fred's age, but instead of f, we're going to use s plus 1. And then we also have Mark's age, which is, instead of Mark, or instead of m, it's going to be Stan's age plus 2. And those all add to make 186 years. So now what we're going to do is we're going to combine these unknowns. We've got 1s plus 1s plus 1s, and that makes 3 s's all together. Combine the 1 and the 2 here, and that gives us 3, and this all equals 186. So from there, all we have to do is subtract the 3 from all sides, and when we do that, we're left with this 3s, and this all equals 183. So from this point, we just need to do some division. Divide by 3 on all sides. 3 goes into 18. We have 6 times. 3 goes into 3 one time, so there it is. Stan is 61. Well, that means that Fred is going to equal the 61 plus 1, which would be 62. And Mark is going to equal the 61 plus 2, which equals 63 years. So these are the ages of those three people. Well, very similar problem here. We have now Ed, Al, and Ted. Their ages are consecutive even numbers. So that means like 2, 4, 6, 8, those types of numbers. The sum means, again, we're going to add their ages is 78 years. So we're going to do it the same way. So let's say we got Ed's age. Ed's we'll say is E. And then let's go with Al. Well, since Al is 2 years older than Ed, his age is going to be Ed's age plus 2. Ted, he is 4 years older than Ed because he's 2 years older now, and he's 4 years older than Ed. If you just look at this right here, ignore this 8 here, just looking at the 6, 6 is 4 above 2, so that's why we're adding 4. So now we're going to just use those expressions, E, Ed's age, E plus 2, Al's age, and E plus 4, Ted's age, and add them all together to make 78. So from that point, we just add up the E's. We got E, E, and E makes 3E. And then add up those constants here. 2 and 4 makes 6, and this will equal 78. So from that point, we're just going to subtract that 6 from all sides. So that leaves us with this 3E equals 72. So we just have one more step here. Just divide by 3. And when I do that, that leaves me with E equals, well, 3 goes into, this is a 3 here, 3 goes into 7, we have 2 times, and that leaves us with 1 left over, and it goes into 12, 3 goes into 12, 4 times, so 24 years. So that means Al is going to equal Ed's age plus 2 years, so it's 26 years. And Ted is going to be Ed's age plus 4 years, so that'd be 28. So there it is, 24, 26, 28. Well, those are the problems on tonight's homework. Good luck.